Yo, what's up, guys? Welcome to Linsclub. I'm Lin, and today we are going to learn logical reasoning. First of all, we have to know what statement is, right? So by definition, a statement is any sentence that is either true or false. But remember this, not both, right? So we're gonna take a quick look at 4 examples. So the first one, I was born in China, so I'm Chinese, right? So this is a statement. So the second one, that's equation, like 1 plus 1 equals to 3, right? So obviously this is wrong, but remember this is also a statement, right? Because it is a false statement. We move to the next one, play basketball. I love play basketball, but when you say play basketball, is that a command or a statement? Obviously that's a command, right? So that's not a statement. So the last one, how to flip coins. All right. Obviously, this is a question, right? You cannot say the question is true or false. So that's not a statement either, right? All right. Since we already know what statement is, so we're gonna know how to write down its negation. For example, Kevin is my student, right? Actually, Kevin is my best friend, right? So, and the negation is Kevin is, right, not my student. That is pretty simple. It's two-way easy, right? Let me make some noise. So here is another statement, right? What we say here? We say my students are all NBA players, right? So probably you will say the negation should be my students are not, or we can say none of my students are NBA players, right? That is wrong. Since the original statement indicates that all students are NBA players, all you need to do is to show the statement is wrong by saying, maybe 1 or 2 of my students are not NBA players, right? You don't have to say none of my students are NBA players, all right? That's too absolute, right? Thus, the negation should be my students are not all NBA players. Or you can say some of my students are not NBA players. So this is not the negation, right? And here are some keywords that you should remember. So the first one, you can also say all not, right? You should be not all NBA players. And it's the same meaning as some of my students are not NBA players, right? That's the keyword. And the next one, we're gonna make another example here. So we'll say some of my students are NBA players. This statement is very cautious, right? Because even only one of my students is NBA player can be one of the situations of the statement. So to negate this one, I have to say none of my students are NBA players to rule out all other possibilities, right? All right, obviously, the negation, some of my students are not NBA players, is the same meaning with the original statement. So that's not the right negation. So we should say none of my students are NBA players, right? So we're going to pick up the keywords here to make a table for you guys. And so here, the statement with some, we should say none do, right? We should rule out all possibilities. That's very absolute. So if the statement is all, right? The statement, the original statement is absolute. We can just say like some do not, or we can say not all do, like we did in the first case. The next part we're gonna talk about is the most important thing in this topic, right? It's about the contrapositive. So the sentence structure is if P then Q, we call this a direct statement, right? It's just a notation, it's just a name. It doesn't matter. So it's converse. It's if Q then P, right? And its inverse, we say it should be, we put double negation. If not P, then not Q. And the contrapositive is if not Q, then not P. So I gonna do this like P in the yellow thing, right? Make this one more intuitive, and the Q in purple, right? So for example, if I live in Shanghai, then I live in China. There is no problem with this statement, right? So we consider I live in China is Q, and I live in Shanghai is P. Actually, it doesn't matter, right? So we're gonna change it into 3 other forms, right? So the first one is converse. So the first one, if I live in China, then I live in Shanghai. Okay, I gotta highlight this one first. Okay, so the direct statement is obviously right. And how about the converse? If I live in China, then I live in Shanghai, right? It's not necessarily to be correct. I can live in other cities in China. I can live in Beijing. I can live in Taiwan. I can live in any other city except Shanghai, right? So there is not related to the direct statement. How about the inverse? If I don't live in Shanghai, then I don't live in China. So I don't live in China, and I don't live in Shanghai. Whoa, it's the same thing. It's not right, right? So I can live in any other cities in China, actually. So how about the contrapositive? That's the most important thing. If I don't live in China, then I don't live in Shanghai, right? That is correct, and that is the right interpretation of the direct statement, right? Now I'm going to introduce a very important conclusion, which is direct statement is logical equivalent. It's a new word. I should say equal or share the same meaning, but in math, we call it logical equivalent to contrapositive, right? So its converse is logical equivalent to its inverse, right? This is logical equivalent. So remember this graph. It's very useful for you guys to use in the real math problems. Obviously, there is no connection between the direct statement and its converse or the direct statement with its inverse, right? We cannot say like the direct statement is right, and so the inverse must be wrong. There is no connection, and you don't have to find what is the relationship between these two statements, okay? But actually, in reality, we often make some logical mistakes. Let's check it out, right? I'm a terrible painter, but I did this for you guys, right? So when I say to my girlfriend, I say, if you buy me a PS5, then I like you, right? So there is no problem, and it's not a threat, right? But my girlfriend, who is poor at math, she will say, "Oh my goodness, you mean if I don't buy you a PS5, then you don't like me anymore, right?" So actually, it happens all the time, right? But actually, what is the statement? That's the inverse statement, right? It's not a logical equivalent to what I'm talking about, right? So I talk to my girlfriend, like, in logical reasoning, if I say you buy me a PS5, then I like you, the right interpretation of my statement is, if you don't like me, you should say you don't like me, then I didn't buy you a PS5. Alright, so let's move on to a real problem. So here is the question. Each of the cards shown below has a number on one side and a letter on the other side, right? How many of the cards must be turned over to prove the correctness of the statement for this card? Let's say, if a card has a vowel on one side, then it has a prime number on the other side, right? It's pretty simple. All you guys know that we should turn over the vowel to see if there is a prime number on the other side, right? And so what is the vowel? There is only one, which is I, right? So the answer is 1? No, it's not, right? So when there is a statement in the sentence structure, if P then Q, it should be aware of the contrapositive. So let us write down the contrapositive of this one, right? So remember, if a card has a wall on one side, we consider this as a P, and has a prime number on the other side, we consider this as a Q. The contrapositive should be, if not Q, then not P. So we write it down here. So if no prime on one side, right, then no wall on the other side, right? So besides turning over the card I, we also need to check it out by turning no prime numbers to see if there is no wall on the other side. So we're gonna turn over the card 1 and we're gonna turn over the card 8. If the sentence structure is if P then Q, or it can be written by the form if P then Q, you should be aware of its contrapositive, which is very important in the test.